friends. I hope everyone is doing great, staying safe with your families. And this is very important in today's world. And right now, as we all know, that there is a new variant, Omicron, that has been detected, and it might be severe. So it's better to stay safe, wear masks, and always sanitize your hands. Right. So this is very important, and always stay with your families. Now, before starting this session, guys, I just wanted to request you to please click the bell icon if you like the video, share it with your friends, and please do subscribe the channel. It will really motivate me to make more and more videos on data science and machine learning. And it's free because I want more and more people to get benefit from these videos, start their careers in this amazing field of data science. So uh, please support me so that I can help others as well, right? Now, in today's tutorial, I will start with basic statistics. As I have mentioned in my last video, if you have not gone through my earlier videos, guys, I would request you to please go through them. And I'm making these videos in sequence so that it will really build your foundation, and then it will be easy for you guys to understand different upcoming topics which I will cover. Now, this tutorial on basic statistics, what I've planned is like I've divided into multiple parts, and will continue throughout this course. I mean, this will not be an end. When and where it is required, I will include one or two videos on the statistics for that particular algorithm maybe, or for some modules, right? Remember, guys, statistics plays a very vital role in data science understanding, right? So we cannot ignore it. So it's better we start. Okay. So without further ado, let's get started. Okay. Give me a moment. Okay. So what are the things that we will cover in today's tutorial? I've listed them. listed them. So mean, median, mode. What actually are mean, median, mode? Okay. What is variance? What is standard deviation? What is correlation? What is covariance? What is population? What are samples? And what actually is the data that we are dealing with? So in my previous videos, I have talked about data, right? And data plays crucial role in model building. So what is actually the data? What are the types of data? We'll understand today in this class. So start with let's first of all try to understand mean, median, mode. I guess this is something that we have already studied in our plus 10 or plus 12, but let me refresh our understanding back in our school days. This particular three topics, they are also called as measure of central tendency. Now I will come to this part where why it is called measure of central tendency. What actually you mean by central tendency and all. So for now, just be patient with me, and back in the mind, just think that okay, mean, median, mode. This is nothing but some measures of central tendency. When we speak about variance and standard deviation, I will also come to these topics. These are the measures of dispersion. Again, what is dispersion? I will come to that as well. Okay. Then correlation. Correlation, the very word, right? Correlation, what exactly it means? Covariance, population. What is a population? What is a sample? I will cover all of these topics. Now let's first of all discuss this one, mean, median, and mode. Okay, to start with, what is a mean of any data set? Right? What exactly is a mean? Mean is also known as average. Mean is also known as average. Let's say we have numbers like 2, 3, and 5. Let's say 2, 3, 5, and 4. Okay, so these are the four numbers we have. So if someone asks you, okay, what is the average of these four numbers? How you will calculate? So what you will do is you will add up first of all these numbers, and then you will divide by the total number of observations. So here the total number of observations is how much? 1, 2, 3, and 4. So divide by 4. Ultimately, mean will be how much in this case? So 5 plus 5, 10, 10 plus 4, 14, 14 divided by 4, right? So it will be 3.6 dot dot 6 then something, so 6.67 or something like that, right? So this will be the mean. How you calculate the mean? You add all the numbers and then you divide it by the total numbers, right? So this is mean. Okay, now when we speak about median of any data set, how we find out the median, right? Let's say we have these following numbers: 2, 4, 6, 1, 3, now maybe 5, 8, maybe 10, 7, like this. And someone asks you, okay, tell me the median of this data set. So to calculate the median, first of all, we need to know how many observations are there. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 observations. Okay. So first of all, we have to sort this data. We have to sort this data. So how we will sort? So 1 will come here, then next number is 2, then 3, then 4, then 5, then 6, then 7, then 8, and finally 10. After sorting this data, what we will do? We'll add them. Yeah, and sorry, we'll not add them. So in case of if it's odd, if it's like less than 9, so we divide 9 by 2. And how much we find? It's 9 is 4, right? 4, 4.5, right? So in this case, our median will be 1, 2, 3, 4, 5. So this will be the median, right? Because you see, there are 4 observations on the left hand side, and there are 4 observations on the right hand side. So 4.5 is nothing but if you just truncate this, it will be 5 only. So this will be the mean. So 5 is the, sorry, this will be the median. So 5 is the median. So this is median. Okay, so now if there are even numbers, so this is odd, right? This is odd. Total number of observations is odd, 9. In this case, let's say there are even numbers in the sense even number of observations. So for example, let's say 2, 3, 4, 6, right? In this case, how many observations are there? 4. 4 is even. So if you divide 4 by 2, it is 2, right? So it should be 1, 2. But you see how many observations on there? 2. 1 observation on the left hand side. How many observations on the right hand side? 2. There is an imbalance, right? In case of a odd number of observations, it was pretty simple, right? This is the center. This is the center. So 4 observations were on the left hand side, 4 observations were on the right hand side. So here, this is the median. But in this case, there is an imbalance, right? If you divide same by 2, number is 2. So 1, 2, 3. So ideally 3 should be the median, right? But here you see, if you go on the left hand side, there is only one observation. If you go on the right hand side, there are two observations. There is an imbalance. So how we deal with it? So we deal in this way. We take, so there are four observations, right? So we take the fourth observation and we take the fifth observation. Sorry, I'm really sorry, guys. So if you divide by 2, you will get 2, right? So 2. So we'll take the second observation, this one, plus the third observation, immediately one after 2. So you add 1 to this 2, it is 3, right? So 2 plus 3 divided by 2. So in this case, it will be 3. So this is observation, or you can say position. So what is the position 2? So which element is in position 2? So 1, 2, 3, right? So 3. Which element is in position 3? 1, 2, 3, 4. So 3 plus 4 divided by 2. And it is 7 by 2. So it is 3.5. So 3.5 is the median, right? So you see there are two ways to calculate median. One is for odd values and one is for even values. Okay, but in both these cases, we need to first of all sort the data. It is important. Okay, guys. So this is all about median. Now, the last thing that is left is mode. Let me rub a few portion. Okay. Where will rub? Okay, let me write over here only. Here only. Mode. Mode of any data. So mode basically means frequency. How many times that particular observation has happened in the data set. So frequency. So let's say we have numbers like 2, 3, 2, 2, 2, 4, 5, 7, 6, 2, 3. Okay. So what is the mode in this case? The mode is you have to see the highest number of times the one particular variable has occurred, the highest frequency. So here in this case, it is 2, right? It is 2. So 2 has occurred second, third, fourth, fifth time, and 3 has happened only 2 times, right? So mode of this particular data set is 2, because highest frequency of occurrence of any data. So in this case, 2 has occurred multiple times. 5 times 2 has occurred. 1, 2, 3, 4, and 5. Whereas 3 has occurred only 2 times. So 3 cannot be the mode. So the mode is 2. So in this way, we calculate the mode. Okay. So this is all about mean, median, and mode. I am pretty sure that you might have studied the same in your class 10 and 12, right? Now we will understand why they are called measure of central tendency. So one thing is common in all of them, guys. Can you guess? In every of this particular topic, I'm trying to find out the average. In this case also, I was trying to find out the average. First of all, I have sorted it out. And then if it's an odd distribution, I'm just finding the odd number. I'm finding the middle number, right? Here also, maximum times, what number is occurring? Averagely, it's 2. So all of this is dealing basically with something related to a center or an average of any particular observations, sets of observations. Now I will try to explain this particular thing, measure of central tendency. Let me go to the other screen. Okay, so measure of central tendency. Why we require this, and what actually is central tendency? What is central tendency? Let me give you an example, guys. For example, let's say in a company, uh, there are 5 employees. Okay, imagine there are no, hypothetically imagine there are 5 employees in a company. Maybe it's a startup company. Okay, since it's a startup company, the salary of these employees will not be huge, right? So I'm considering the salary range, let's say 10,000, 10K, and 12K, and 15K, right? And how much? Let's say 9K. Okay. And there is one guy who has vast experience. So he has been given salary of 20K, or let's say 25K. So these are the salaries of the 5 employees. And someone asks you, okay, can you tell me the average salary of the employees that works in this particular company? Let's say it's any XYZ company. Let's say someone asks you, tell me what's the average salary of this company? So how you will calculate? First of all, you will get to know how many employees are there, and then you will get to know their salaries. So in this case, this is the data that is available to you, and number of people is 5, and the data is this. So how you will find the average? You will try to calculate the mean, right? So how will calculate the mean? 10 plus 12 plus 15 plus 9 plus 25. K I can write here. K is nothing but 1,000, right? So let's, for simplicity, I have written over here, right? Divided by 1, 2, 3, 4, 5. So we have 5 employees, so 5. Just we have seen in the previous screen, right? So mean or average will be this. So if you calculate the average, how much it will be? Let me pull up my calculator. So it will be 10 plus 12 plus 15 plus 9 plus 25 divided by 5. So it will be 14.2K. Okay. So it will be 14.2K, right? So this is pretty much okay. So that means that average salary that is been earned by each employees in the company is roughly around 14K. So you will say, whoever have asked, you will say, okay, 14K is the average salary in that particular company, right? So you see, is it the case? Someone is earning 10K, someone is earning 9K, someone is earning 12K, 15K, 25K. So we can say, okay, fine, 14K is somewhat acceptable. Right? Now, let's say instead of this 25K, someone is earning, let's say, 50K. 50K. Now let's calculate the average. Now let's calculate the average. So in this case, it will be 10 plus 12 plus 15 plus 9 plus 50K divided by 5. So again, let me calculate. So it is 10 plus 12 plus 15 plus 9 plus 50. divided by 5, it will be 19.2. So it will be 19.2K. Now see the difference, guys. What I'm trying to say here is, because of the presence of this particular guy, the average is increasing. Earlier it was 14K, now it shifted to 19K, right? Just because of this guy. Just because of this guy, now the average salary is 19.2K. Is it acceptable? No. If someone tells you, okay, the average salary is 19.2, for any new fresher who is trying to join, he will find it safe, right? Okay, I'm getting 19K. But actually, you see, actually the salary, maximum salary is within this range, right? 9, 15, 12, 10. And this is if and here you, when we calculated it, it became 19.2 just because of this particular guy. This is also an outlier. I've discussed this in class 1, right? This also can be termed as an outlier. So you see, average is shifting because of the presence of higher values, right? So it will not give you the accurate result, right? So our job is to get in between this range. Our job is to be present in between this range so that I can guess approximately the average, and which will help me, right? So if I give a right result, if I give a right result, my prediction will be right, right? Right result will leads to right prediction, right? But because of this particular guy, my whole result, my whole prediction is going wrong. This cannot be considered as the average. So the mean fails there. Means fails in calculating the average. Why? Simply because it is not in between this particular range. It is not in between this particular range. We don't know, right? So our job is to make this particular average in between this range, which is not possible with the help of mean. So what we will do? We go to the next approach, which is median. Okay. So let me rub a few portion of the things, guys. So now we will see with the help of median. So in median, what we'll do? We first sort the data, right? This we have seen in my previous screen, right? So we will sort the data. So whatever data we have, let's say 10, 12, 15, 9. So 9, sorry. So 9 plus 10 plus 12, sorry, it will not be plus. Let me allow this. So we'll arrange it first in the ascending order. So it will be 9, 10, 12, 15, and then 50. Let's say 25, 50. Now here, how many observations we have? 5 observations, right? 5 divided by 2 is nothing but 2.5, which is nothing but 3. If we just do the trunk, if we truncate it, right? So 3 is nothing but 1, 2, 3. So 12. So 12K will be the average salary of company X, Y, and Z. So will it solve the problem? Yes, right? So just by sorting this particular data, we have nullified the effect of an outlier, right? And we are placed in the center. We're placed in the center, right? So median will solve our problem, this particular problem. There may be other scenarios also where median also will not be able to help you. There may be, right? But in this case, it does. It solves the purpose. Now, if someone says you 12K is the salary, so we'll get an idea, okay, this 12 is lying in between these particular values. So more or less correct prediction. Similarly, let's say there are salaries like 10K, 12K, 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 10K, 50K, 100K. So in this case, guys, in this case, mode will help us. Mode will help us because you see, we are having multiple times the same observations. So here we'll say, okay, the average salary is again 12K. So you see how important this particular three topics are: mean, median, and mode, right? Now, if you see closely, everywhere I'm trying to be in the center, everywhere. Why I want to be in the center? Because if I am in the center, my accuracy will increase and my predictions will increase. I will be able to approximately guess the right value, right? So always there is a tendency to be in the center, in the center. That is the measure of central. So these particular three things, they are the measures of central tendency. So our data should be, the average should be lying in the within the center. It should be located centrally. Then only we can guess particularly what is the average. So that's the measure of central tendency. How we measure it via mean, mode, and median. These are the measures for central tendency. Okay. So if my average is in the middle, if my average is in the middle, then it's better, right? My predictions will be better. So this is all about central tendency. Okay. So let me go back to my first. So here we covered what is mean, what is median, and what is mode. Now let's discuss about variance and standard deviation, which are again measures of dispersion. What is dispersion? I will come back to that. But variance and deviation. So let me go to a next screen. Okay, so variance. What is variance? So we discussed mean, median, mode, and right, and we know the measure of central tendency. So if we are in the middle, it's better for our predictions. So let's say, let me draw a curve, a plot. Okay, x-axis, y-axis. You can take it anything. Okay, and let me draw a plot like this. Let's say this is the mean. We have calculated the mean. Mean is also denoted by mu. Okay, mu or x bar. Now I will come to when we will say mu and when we will say x bar. I will come to that. But this way, these are the way we denote mean. Okay, so now for now, let's say we denote it by m only. So this is the mean of this data. These are various data points. These are various data points. Let me put it this way. These are various data points, and this is a particular curve that we have drawn out of these data points. Let's say there is data over here, data over here, data over here, data over here. Okay, these are points. X, okay, let me also give you the x coordinates. So let's say this is age. X is nothing but age. And this is, let's say, salary. So we are plotting a graph between age and salary. Okay. There is a particular name for this graph. I will come to that as well. Not now. Okay. Let's say we are drawing a graph between age and salary. So you will see that as your age grows, your salary will also grow, right? It's quite obvious, right? Because initially when you are small, you do not earn. And once you pass from any university and when you graduate, or when you're doing a business, so there is a particular age when you will start doing it, right? So slowly, as your age increases, your salary will also increase, and you will reach the peak of your career at one point of a time, right? Now, after that, when you grow old, your salary again will decrease, and when you will retire, it will be only the pension or some of your savings, right? So this is a salary. Let's say this is a graph of a salary and age. And these are the data points, various data points. We've collected like 500 observations of different people from various backgrounds, and from different age groups. And we have plotted their salaries. So the graph will look like this, something like this. Okay, so these are all the data points. Now, what I'm trying to say is, let's say this is the mean, this is the average. Okay, because we have data points over this side, data points on this side. Let me take this. Data points on this side, data points on this side, right? So this is considered as the mean. This is the average. So what is variance? Variance is like how far the points are from its mean when they are plotted. That is known as the variance, meaning how spread is your data. Whether your data is very near to the mean, like this. So let's say this is the mean. How spread is your data? It is very close to this mean, right? Or it is like this. Let's say this is the mean, and these are all the data points. So this is the spread of the data, right? This is the spread. This is the spread, right? So how spread is your data from your mean? This is the mean. In this particular case, the spread is very small, right? In this case, the spread is very large, right? So variance is a measure of dispersion. So dispersion is nothing but spread. Dispersion give me a minute, guys. Some okay. Let me run this. So dispersion is nothing but spread. How spread your data is from your average. Okay, and variance is the way to measure that. Variance will measure it, how spread your data is. This is variance. Now there is a formula to calculate variance. So variance of, let's say, variable x. X is nothing but a variable. Variance, how to calculate variance? It is, so you know this is mean, right? This is mean. So x of I minus x whole square divided by total number of observations, where xi, and this is like wait, this is summation of I is equal to 1 to n, or in this case, yeah, n. So xi is the observation at ith value, and we'll sum them up. Right? N is the total number of observations. Total number of observations. So you see, let's say you have been given a variable x. Let's say there are a couple of values here: 2, 4, 7, 8, 10. How will calculate the variance of x? In order to calculate the variance of x, you need to do this particular formula. So here in this case, the formula will be like this. It's summation, right? So x of I means I is nothing but the position. So here total number of n, here n is how much? 1, 2, 3, 4, 5. So n is 5. And then you have to first of all calculate the mean. Sorry, let's calculate the mean first. So the mean will be x bar, let's say, and the mean will be nothing but 2 plus 4 plus 7 plus 8 plus 10 divided by 5. This is the mean, right? So let me calculate again. 2 plus 4 plus 7 plus 8 plus 10 divided by 5. So it is 6.2. So mean is 6.2. So how will calculate the variance? It will be 2 minus 6.2 whole square plus 4 minus 6.2 whole square plus 7 minus 6.2 whole square plus 8 minus 6.2 whole square plus 10 minus 6.2 whole square divided by 5. Right? So if you calculate this, let me rub this. Okay, so if you calculate this, you will get some number, right? I'm not calculating the number right now, but this you can easily calculate. So this is the variance actually. Variance of x. This is how we calculate it. This is the observation at location 1. This is the observation at location 2. This is the observation at location 3. This is the observation at location 4, and this is the observation at location 5. So x of I minus mean, which is this one, whole square, this one, plus, since it's a summation, so plus again the same, x of I minus 6 mean 6.2 plus, and ultimately we divide everything by 5. The total number of observations. Total number of observations is nothing but 5. This is how we calculate the variance. Why it is important? Why variance is important to understand? Because if the whole point is our data should be very much close to the mean. Our data should be very much close to the mean. Why we say this? Because if our data is closer to the mean, only then our accuracy will be high. Why accuracy will be high? Because let's say I know the average. So by knowing the mean, I can guess, right, what others values may be. So in this example you saw, right, if I go back to this one, so if I know the mean accurately, I can guess the average salary, right? So I don't need to know the individual salaries of each employees. If I know the average, I can guess, okay, what is the salary range in their company, right? So that's how it is important. So if my data is close to my mean, right? So then my predictions will be accurate, and based on the average, I can calculate my predictions. So that is how important variance is, how it is important to know what is the spread of the data. If the spread is high, let's say in this case, the data are far away from the mean. This is the mean, right? Far away from the mean. In this particular case, if we calculate the if we use mean, or if we use the average, then our accuracies will be less. Our predictions will not give us accurate results, and we cannot consider mean to be a measure to know anything. For example, in this case, if it's the salary as I was discussing, right? Salary is 50. We cannot use the average because the data is spread here. In this case, if you draw this particular thing, in this case, data might look like this. If this is the mean, and there can be 25, 50. So you see, spread is high. So if the spread is high, if the variance is high, then mean or the average will not give you, it will not be a right measure to know anything about that particular topic. For example, you want to know the average of the average salary of the company. So by calculating the average, you will not be able to guess properly what is the um, average salary of the company simply by just using mean. That's how it is important. So variance is very important, and variance is nothing but measure of dispersion. What is dispersion? Spread of the data. Spread of the data from the mean is variance. Remember this point, guys. This is very important. Spread of the data from the mean is variance. Okay, so how it is calculated? Variance is calculated by this formula: summation of xi minus x bar. X bar is nothing but the mean of the total observations present in x bar. So this, let's say I give you an example. These are the observations present in x. What will be x bar? You calculate the sum divided by the number of observations. You get this. This is the mean. Now the variance formula is xi minus x bar divided by n. So what actually we are doing? Xi minus x bar, meaning, let's say this is a point over here. This is a mean, right? And this is a point over here. So we are calculating the distance in a way. Think of in this way. Xi is nothing but this point, right? Meaning mean is this one. If you see this is the x location, right? So we're calculating this, and we are finding the and dividing it by n. So because there are many observations over here, so we're trying to find out the distance from the mean to all the points. And since why we are squaring it, since it can be a negative number also, right? If the point is somewhere here, it can be a negative number. Xi minus this one will be negative. So we want to just make it a positive number. That's the reason we are squaring it up, because -1 and -1 is nothing but 1 plus 1, right? So square is, that's why we have put the square. So basically we're calculating the distance of this particular point from the mean. Xi minus x bar divided by n, summation of the entire x observations. This is all about variance. Now the other topic is this about standard deviation. Standard deviation. This standard deviation also is a measure of dispersion. Right? So variance formula 1 by n summation of I is equal to 1 to n x of I minus x bar whole square. This was the formula for variance, right? This is the variance we just saw. And what is standard deviation? Standard deviation is denoted by sigma. This is the symbol for standard deviation. Sigma is the root of variance. So in this case, it will be root of summation of I is equal to 1 to n x of I minus x bar whole square divided by n. This is standard deviation. This is standard deviation. Okay. So it's nothing but square root of variance. It's the same. It also measures how spread is the data. Normally, in our statistics or in our data science, we talk about mean and standard deviation. These two. That's why I first of all made you understand the variance part, because standard deviation will be square root of the variance only. And in our upcoming lectures, we'll talk only about most of the time we will talk about mean and standard deviation. So you know what is mean and you know what is standard deviation. Standard deviation is a measure of dispersion and it is the square root of the variance. Variance is nothing but xi minus x bar whole square divided by n. This is the formula to calculate. Okay, so this is standard deviation. So ultimately, what we're doing is we're trying to find out how spread our data is from the mean. So let's say if I draw a line, and let's say this is the mean. Let's say we denote it with mu or x bar, whichever you feel comfortable with. Okay. So this is and this is the mean, right? So this is the mean, and there can be data here, 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 anywhere, right? Here also, near, far, everywhere. So what actually what I'm trying to say is, let's say this till here, till this portion, it is one standard deviation. Here also same, -1 standard deviation. Similarly, here also it will be 2 standard deviation. Here also it will be -2 standard deviation. Here also it will be 3 standard deviation. Here also it will be 3 standard deviation, and so on. Okay, so this basically helps us to calculate the spread of the data. You know, this is the graph, right? I just show you the graph, right? So till this, it is considered as one standard deviation. One standard deviation, and there is one empirical formula as well. I will come to that later. Just for now, understand that all the points in this particular range, all the points, sorry, let me mark it with the red one. All the points in this particular area, they will come under one standard deviation. This is called one standard deviation. All the points between this range, let me use another marker. So all these points will come in third standard deviation. Similarly, let's do this. All the points falling in this range will come in third standard deviation. So this is second standard deviation, and this is third standard deviation. And why I am saying this all things? Why I am mentioning a standard deviation, one standard deviation, second standard deviation, third standard deviation? Why I'm mentioning it? I will come to that, guys. There is a formula that we will understand in our upcoming classes, which is like 68% of the data set, 95% of the data set, 99% of the data set. I will come to this. Okay. So, okay, so to give you a heads up, so one standard deviation means 68% of our data set will fall in this range. 95 means second standard deviation. meaning 95% of the data will come in this range. Okay. And 99% of the data will come in this range. Okay. So 68% of the data will fall in this range. Then 95% of data will fall in this range, second standard deviation. And this is 99% of the data will fall in this range. Remaining all are considered as outliers. Outliers. And this is also known as the tail region. This is also known as the tail region. I will cover all these things. I'm just giving you a heads up. Okay, so you know what is standard deviation. So let me repeat again. Standard deviation is nothing but is a measure of dispersion, meaning we want to know how much spread is our data from the mean. Okay, it is important to know that. Why? Because if we know how much spread is our data, we can know that whether we will use mean to calculate the average or to know something about that particular population or particular problem statement. For example, salary of the particular company. So if the data is spread, let's say someone is earning 10, 12, and 50 and 70 and 120K, you see the mean. If you look at the mean and the spread of the data will be huge, right? If you calculate the mean, it will be somewhere here, and this is 1 point, this is 1 point. You see the distance spread is huge. So this particular average, if someone asks me, okay, what is the average, I will say 65. Let's say 65K is the average. Whether this is the right prediction for that particular company, whether everyone, most of them get 65,000 salary, no, because there are many guys who are below 50,000 salary. So in this case, 65,000 salary cannot give us the right prediction for the average salary of that particular company. So this is all about standard deviation. Now let's say, so what are the things we covered? We have covered mean, median, mode. We have covered variance, and we have covered standard deviation. Now let's discuss about correlation. What exactly is correlation? Okay, so the next topic is correlation. Oops, wait guys. Let me rub this. Let me rub this. Okay, so correlation. What does it mean? So the name, right? Co relation. So meaning there is a relation, and co meaning there will be a relation between two entities, right? Two entities. So relation between two entities. So we are trying to find out the relation between two entities. Find the relation. This is correlation, right? So we are quantifying. So if someone asks you the definition of correlation, you can say quantifying a relationship. Quantifying a relationship between two variables. You need to find out the relationship between two variables. What does it mean actually? Means, let's say we consider two variables, x and y. Okay, let me take a different marker, x and y. So if x increases, whether my y is increasing or decreasing. This is what we'll study with correlation. Similarly, whether if x decreases, y increases or y decreases. right? So we need to find out the relationship. So this is correlation. We're trying to find out the relationship between two entities. That's the term used, correlation. Whether the two values are correlated, meaning we're trying to find out the relationship between two variables. Whether if one increases, the other also increases, or whether if one decreases, what is the impact of it on the other variable? So that is correlation. Okay. So now, why it is important? Because let's say we have input features, right? We have input and we have output features. Now, when we are building a model, it is very important to know what are the important input features. How we will find important input features? We need to find out the correlation of input and output features. So now you know, right? When I will use the term correlation, you will quickly guess, okay, meaning what is the relationship between the input and the output variable? When I will say, okay, what is the relationship? What is the correlation between two input variables? Meaning, okay, is there any sort of relationship between two input variables? That is also quite crucial when we're building a model. Ideally, we should not consider both the elements or both the input features if there is some relationship between them. I will discuss this as well. Okay. So for now, just understand what is correlation. It's a relationship between two entities or two variables. Okay. So now we know correlation. Now let's study what is covariance. What is covariance? Let me rub this, guys. Let me rub this. Now that you know what is correlation, it will be easy for you to guess what is covariance. Okay. So covariance again is the same thing. It quantifies the relationship between two values, two variables. So whenever you see variance, right? We normally know, okay, variance is nothing but how spread is the data from the mean. And this is co. Co means two, right? So we know co-ed, right? What is co-ed high school? Means boys and girls school, right? So co means two, dual. So here also correlation means relation between two entities or two variables. Covariance meaning we need to find out the relationship between two variables. Okay, same concept is same. If one increases, let's say we have x and y. If x increases, whether y increases or decreases, and when x decreases, whether y increases or decreases. So covariance is a study, or covariance is like quantifying the relationship between x and y. Now, what is the formula for it? How we calculate this? There should be some formula, right? So the name suggests covariance. So it might have come from variance, right? So we know the formula for sorry, for variance. What is the formula for variance? 1 by n. Summation of I is equal to 1 to n x of I minus x bar whole square. This we can also write it as 1 by n. Summation of I is equal to 1 to n xi minus x bar into xi minus x bar. Same thing, right? Now covariance of two variable x and y is nothing but 1 by n summation of I is equal to 1 to n x of I minus x bar y of I minus y bar. This is the formula for covariance. Okay, this is the formula for covariance. Now, its covariance can be negative, covariance can be positive. Here we are not squaring, right? In this case, in variance we are squaring, so it will always give us a positive value. In this case, this number, this thing can be a positive, this can be a negative, we don't know. Or this can be positive and this can also be a positive. Or this can be negative, this can be positive. Or this can be negative and this also can be negative. Any of these situations may arise. So covariance can either be positive or covariance can either be negative. If it is positive, if covariance of two variables is positive, means when x increase, y also increases. If covariance of x and y is negative, means when x increases, y decreases, and vice versa. So this is the formula for covariance, and this is what actually covariance is. Okay, one of the demerit of covariance, I will come to that, is it does not give you the magnitude. Demerit or disadvantage, you can say, it does not give you the magnitude of how much positive and how much negative they are. How much positive or how much negative they are. Because here if we'll get some number, right? So we'll get some number. Let's say it is minus 0.45, or let's say minus 11.62, or let's say plus 20.3, something like this. This number doesn't make any sense in this formula. The only thing that matters is the sign. Only thing this matters is the sign. This sign is important. This basically tells us whether it is positively uh, uh, they have an incremental or they have a decremental relationship between each other. It only tells us this. This number doesn't have any sense. That is the demerit of covariance. It does not give us the magnitude. So we cannot say this is the magnitude of negative relationship between these two variables. We cannot say that. To calculate the magnitude, we have uh, one more function, or let's say one more formula, or let's say one more statistical term, which is called Pearson's correlation coefficient. We'll come to that in later stages of statistics. But for now, understand what is covariance. Covariance helps us to quantify the relationship between two variables. So these are the two variables. If you want to know whether they are related, whether they are positively related or negatively related, you can know by the formula. This is the formula. So this is the formula for covariance, and this is important. This is important because at any point of time, we want to know what is the relationship and where is the graph between two variables. So this is very important, covariance. So we learned quite a few topics today, right? I guess you will be able to understand what I'm trying to say, right? So we covered correlation. What is correlation? We covered covariance also. Now, population and sample. So let me, sorry guys. Okay, so now let's discuss about population. What exactly we say when we say population and sample actually. Now, if I speak about population and sample, now you can correlate because most of the topics we have already covered. Okay, so let's say we have a state. Okay, we have a state, and we have, there are many people in the state, right? So this entire state, and these are like, let's say these are people. in this particular state. Okay, so this whole state gives us the population. Okay, so this gives us the population, and sample will be some portion from this population. Let's say this. Okay, so this can be a sample. Now, why I'm saying you this? Why all of a sudden I'm saying you this? Imagine you have been asked to calculate the average height of the people in this state. What you will do? This is your job. Let's say. Okay, someone asks you, okay, can you calculate the average height of the pupil in this particular state? So what you will do ideally? So you know the formula, right? So mu is the mean, right? So mu basically is the population mean. Mu is the population mean. In my last slides, we talked about mu x bar, right? So this mu basically is this one, this population mean. If we know the population, if you know how many people are there, what is the height of each and every individual, if you can collect that data, let's say, then it will be denoted by mu. So the mu will be the average of that. So mu will be 1 by n summation. You know that, right? 1 is equal to 1 by n x of I. It's the mean, right? We just saw in the previous slides. And what will be the mean of the sample? So this is actually sample mean. Sample mean. X bar will be 1 by small n. Summation of I is equal to 1 to small n x of I. Right? So n is the total population. N is the total population. And this small n is this sets of people. So this is the sample mean. And this is the population mean. Okay. So now let's come to this particular topic. Let's say someone asked you, well, can you calculate the average height of the people in this particular state? Now let's say you don't know the total number of people in the state. And also it will be very hard for, let's say there are 1 million people in this particular state. You cannot go to each and every house, and in the house also there will be many people. You cannot go to each and every house and then collect the data and then calculate the mean. I mean, it will be possible, but it will require lots of manpower, and which is not a smart move as well, because just for calculating the height, you are going to each and every household and calculating the data, and then finally you're calculating the mean. It's not a smart move. So what you will do? We'll collect sample from this population. Let's say we collect sample of 10 people. 10 people from this entire population of 1 million, and we calculate the mean, right? So we calculate this. So let's say we calculate the mean. So the mean, the average height may be somewhere around, let's say 5.7. Let's say 5 feet 7 inch. Okay, 5 feet 7 inch. So we can guess, we can make a guess that the average might be either close to 5.7. When I say average, means average population or average mean of the entire population might be close to 5.7, but we don't know. We don't know, right? Because we just collected the observations of 10 people and we have a population of 1 million. So how we know? How we know that X bar is similar to mu? Any guesses? So if we increase our n, maybe the average of the sample mean may be equal to this population mean. If we increase the n from 10, let's say now we increased the number of people, let's say 10,000 maybe, let's say. So if n is close to the capital N, meaning the total number of population, we can say that sample mean will tend towards the population mean. Right? So it completely depends on the number of observations that we have in hand. If n is big enough, then we can say that the average, then we can easily guess the average height of the people in this particular state. If we just increase our sample means n, if we increase the number of observations in the sample, then we can approximately say that this 5.7, right? This 5.7 may be the average height of the state. What is the condition? Condition is n should be close to n. This is all about population and sample, guys. Okay, so the population, just remember one thing, population is given with mu. This is the population mean, and sample mean is given with x bar. Normally, in our experiments, in the hands-on, everywhere with what we do is we have the sample. We don't have the entire population. It's very difficult to get data for the entire population. Yeah? We always have the sample. And so we calculate the sample mean only. It is not possible to calculate the population mean for any data. For example, let's say we want to have a problem statement in hand. Last time we discussed, I guess, right? The average sell, the house price, right? The house price data that we had in the first tutorial, I guess I have discussed. There actually we have the sample of data. We didn't have the entire data set. It's not possible actually, because of the population, right? Because of the additional manpower that is required. So we always have the samples. We always consider the sample. If luckily for us, if in let's say a few cases, we know if the population is very small, then we will consider some population mean, no problem with that. But the population is very high, we have to consider the sample from the population. So in that case, most of the scenarios, we are considering sample and the sample mean. Okay, so this is all about population and sample. So now you have some idea about what actually is a population and what actually is a sample. Sample is taken from the population. Okay, so this we covered. So we covered population also, and then we covered sample also. The last thing that remains is the data. Okay, so data. Now I've always talked about data, right? So let me go to the next screen. Okay, so I have always discussed about data, that we need data for machine learning, right? So we need to know what actually data are, what are the categories of data, right? So data can be broadly classified. So data can be broadly classified into qualitative data. Qualitative, let me write it properly. Let me run this. Data can be, sorry guys, qualitative and quantitative. This is very important. Try to focus here. Data can be of two types: qualitative, quantitative. Again, qualitative also can be named as categorical. Okay, so again, this particular category can be subdivided into two. Okay, nominal and ordinal. Categorical, like classification that we discussed in our or first tutorial, right? Yes, no, high, low, medium, right? Like if someone asks you ratings, these are all categories, right? Now, nominal. What is nominal? What is ordinal? Ordinal means the data have an order. Nominal is no order. Here we do not consider any order of the data. Here we have to. So the ratings fall in the ordinal category. Yes, no falls in the nominal category. There is no order in yes, no. It can be no or yes, yes or no, doesn't matter. But ratings, high, low, medium, right? This falls in the ordinal category. Or let's say star, 1 star, or 2 star, 3 star. Normally, when we go for to any restaurant, at the end of the day, when you're done, they will give you to rate their service. So we'll rate them either 1, 2, 3, 4, 5, right? So those are nothing but ordinal categories. Now, in quantitative also we have two categories. One is discrete and the other one is continuous. Continuous. Okay. Discrete again can be subdivided into nominal and ordinal, like the categoricals. And continuous, these are just numeric data. Numeric data like floats, floats, integers. I believe you know floats, integers, right? And discretes are basically whole numbers. Deals in ranges, basically. Deals in ranges. So in this case, if we don't have yes, no, we just have 1 or 0. This ideally we can consider it as a discrete. Or let's say we have a variable where the number of observations are like this: 1, 1, 1, 2, 3, 2, 2, like this. So this can be considered as discrete random variable. There can be observations like 1, 1.2, 2.3, 4.5, 2, 3. This can be considered as continuous data. This new discrete data. And the whole of these two are basically quantitative data, because they deals with numbers. This qualitative deals with strings, let's say yes, no, high, low, medium, like categorical basically. So this is all about, this is the data actually. Now in the next tutorial, I will also talk about random variables. I will come to the actual definition of statistics. Still now, I know that I have started basic of statistics, but I haven't given you the definition of statistics, because before that, I wanted you to understand these few topics which are very important. Then only when I start to discuss about the statistics and other distributions and all, I will use these terms frequently: variance, standard deviation, correlation, population, sample, data, mean, median, mode. And that's the reason it is very important to understand first this and then the other topics. So in the next tutorial, I will discuss about what actually is statistics. What is the definition of statistics? How many types of statistics are there? And then I will also discuss about distributions. Okay, I will discuss about plots, different graphs. Okay, so this will be covered in the next tutorial, guys. So thank you for being so patient, and uh, the whole idea, guys, is that I am able to make you understand the topics that I'm covering. That's the whole idea. So if any point of any point of a time, if you feel that this is something that I didn't understand, then please let me know in the comment box. I will make sure that in the next video, I will try to explain them. Okay. So thank you, guys. This is it for this third tutorial, and please like the video, click the bell icon if you like the video, and subscribe my channel and share this with your friends, your colleagues, whoever they are, because as I said, I'm trying only to help you guys, so that whatever I know, I'm just sharing free of cost. And if you share, if I'm able to build a community of people who are trying to shift their career in data science, I will be happy to do that, and it will really motivate me to make more and more new videos. Having said that, stay safe, happy coding, and keep shining. Thank you. Thanks a lot.